Good evening, people. I'm Titus, and today we're going to continue our camera mini-series with part 6. In the last video, we set up some basic aiming and shooting functionality that we're going to basically expand upon. So in this video, I'll show you how to disable the camera system on like a set interval, and then we'll have the camera come back to life, because currently, if we shoot it, kind of nothing happens, so it's not very lively or useful. So let's go ahead and get right into it. So there's a few ways we can implement the code. We could set it directly in the camera blueprint as a collision event, but we've already played around with some interface code, and I think like an on damage event is a very good use case for a blueprint interface, so we'll kind of stick with that, and we'll just create a new interface for damage, basically. So let's right click and go to blueprints, and we will set up the blueprint interface. Call BPI_damage. We can go into that and call a function, maybe you shot me. I'm gonna add another function here as well called recovered. And then you can compile and save that and close it out because we're actually done with that. So now the next thing we need to do is we need to set up our camera to actually receive the damage. In order to do that, we will want to go to our class settings, add in the new interface, BPI_damage, and then you'll see it in the interface section, but we won't be able to call the event for you shot me until we compile. Then once you do that, the you shot me will come up, or whatever you named your function. All right, so from here, we can basically, if you guys remember in the beginning of the series, we are moving the camera system through a timeline. So this top code here is basically using values from a timeline and using a lerp rotator between two rotation values. Specifically, we're going from a positive yaw to a negative yaw, and that's how it's sweeping from left to right. And then we're storing that rotation value in a variable we created. So we're going to do something similar. So in order to, when we disable the camera or when we shoot it, I want it to kind of just droop down or pitch down. But in order to do that, we're going to have to stop the camera movement component from playing. So on the left-hand side, you have a component section, and you can see the camera movement reference is actually right here, and that's the same as this guy right here. So what we can do is we can drag this guy out, get a reference, and then if you just drag off him, there is a stop function. So we can hook that up like that, and that'll stop the original timeline from playing. So now we're going to want to create a new timeline for our disable. We'll call it maybe disable camera. And this one we'll actually want to hook up from our play from start because we're going to have the camera pitch down, so you don't want a situation where the camera's kind of only going to run that timeline in the middle of an already ran timeline. If that kind of makes sense. You always want to play it from the beginning, because we should set up some Boolean values to make sure that we can only disable this camera once. So we'll kind of do that a little bit later though. But yeah, so we're going to hook it up from the play from start. And we're going to do the same thing that we did at the top of the code. So we're just going to get a reference to our camera and drag off that and do a set relative rotation. And I'll put this up here like that. Now, originally we just did a lerp rotator, which basically will smoothly blend between two rotation values based on an alpha. So if the alpha is 0, it's going to be at this rotation. If it's at 1, it's going to be at this rotation. If it's somewhere in between, it's going to calculate the distance between those and kind of give you like a mix of both. So it's a very useful function. So what we would do is we would create two rotators, and we can grab this and just copy pasta, and you can hook up your bottom one and your top one here. So we can make this rotator our current position, and we're going to make this rotator where we want the camera to go to. So when the camera is disabled, I want this guy to look down, so kind of pitch down, kind of like that. If we look at the camera in the map, it's currently pitched at negative, it was at negative 20. So I think maybe we'll pitch it from negative 20 to negative 80 will probably be where we're going with it. So the second value will be where we want it to go to, so we can just manually put in negative 80 degrees. Remember, for the roll, we haven't rolled this camera once, so you don't really need to mess with that at all. And then the yaw, we can do the yaw a couple different ways. So we have a variable that is storing the last rotation, so we can do a get on that, and then we can right click and split it. And if you wanted, you can just simply punch in your pitch values and your yaw values like that. You can connect the roll if you want to. It doesn't really matter. We haven't changed the roll at all, so this will work connected or not. And just this code right here, when it runs, it's going to lerp. It's going to go center and lerp down. So it's going to go center and down, basically. If you don't want that, if you want to go straight down, you would want to hook up the yaw here as well. We'll kind of test it with both here so you can see what I mean. So we'll do update on this guy, and we need to hook up our return value here. And now we need to set up our timeline real quick. So I think for the timeline, we're just going to do just a regular float track, and it's going to be our lerp alpha, because we're just using this to control the alpha. We'll create the first keyframe at 0, 0, so at the beginning. And then we'll create the second keyframe where you want the camera to go to, which is after, I think, 3 seconds will probably be good. And then I want it to be at the full value of 1. And then we'll make our timeline about 6 seconds long. So you can see it's basically gonna hit our alpha of 1, which is pitched all the way down, and then it's gonna wait and sit there before coming back to life. So just with that, this basic code should function, but we do have to set up a way to actually trigger the camera now. So I'll also give you a alternative setup for the timeline as well that might be you might want. There's a few different ways to do it, so I'll show you both. But let's plug in our alpha into our alpha value before we forget. And now let's go into the bullet. And we need a way to be able to make this bullet hit the camera. So what we'll want to do is under the trigger capsule, we can highlight that and then right click and add an event for it. And it'll be a collision. And on the begin overlap, like that, you can simply drag off it and do a cast to our BP underscore camera. So we're in the bullet, we're going to cast to the camera. You can plug in your other actor into your object here. And then from here, you can actually get a reference to your interface. So get all actors with interface. Our interface, we call it, was BPI underscore damage. So BPI underscore damage. Now you could have multiple actors that has this interface. So if you want to cycle through all your actors, you can just call off a for each loop. Plug in your array. And then off that, you can drag off and do a call to the function that you named it, which I think was you shot me. Make sure you select the you shot me with the parentheses message, because that means it'll call it on all devices. Sometimes you'll see it without it. It just means if you run the one without it, it's gonna it'll only run in that blueprint. So I think if I do it over here, yeah, you shot me. So you see how it doesn't have the actual message icon. So this would only function actually in this blueprint. So make sure you get the one with the little envelope. And then we can plug in our array element to the target. And there's going to be some issues with this. We'll kind of address them as they come up. But I think it'll function. So let's give it a test here. So now if I shoot the camera, you can see it kind of goes down. And then after 6 seconds, it should come back up. It's not going to return to its patrol though, because we haven't activated the original timeline. So we can go back into our camera, and after we set the relative rotation, we can actually get a reference to our camera movement component. And then I think if you just drag off that and do a play from start, or even play, either one of these should work. That one should pick back up the patrol. So let's go ahead and test that real quick. So it goes down. We'll probably want to turn off the light too. Should pick back up, and then it's going to go back into its timeline patrol where it's, you know, going left and right. So it's looking pretty good. Just for a little bit of, so it looks a little bit more believable, we can get a reference to our spotlight, drag off that, and do set visibility. And we'll turn it to off. And then you can simply copy pasta that. And we'll turn it back to on. Now you're going to notice something, the timeline, and it's probably a good thing to make note of. So let's turn this on. Now you would expect that this code would run after the timeline, so after the 6 seconds, but the code after the timeline will actually run unless you're doing in finished. So because it's an update, it's going to execute all the way through. So this camera or this light's not going to turn off. And that's because it's just turning on really quickly. So the way around that is that you can either hook up the finished pin to it and do it through the timeline, which can be buggy sometimes, or you can simply call a delay and just make it the length of your timeline. Either way will work, doesn't really matter. So now when we shoot it, camera goes down, light turns off, waits 6 seconds, light should kick back on, and it'll move back into its patrol. So like that. Now if you notice, the camera goes center, whoops. So it goes center and down. So if you don't like that behavior, you can plug in the yaw value into your bottom rotator. And what it'll do instead is it should just droop down from wherever it's at. So maybe you like that a little bit better. That's how you can get that functionality. So either, you know, it's basically, you know, whatever design you want. Another thing to note too is if you, instead of doing it through alert rotation, like we did initially, you could go into your timeline and instead modify the pitch, because the pitch is the only thing we're changing. So you could simply, instead of a alpha track, you add another float track and maybe call it your pitch value. And if you remember, we would add 2 keyframes. Our first keyframe is going to be the current value. So at time 0, our current pitch was -20. And then your second keyframe would be at, in this case, 3 seconds, and whatever pitch you desire, which was -80. And then you can make your timeline as long as you want it. And then when you go back to the event graph, you notice we have a pitch value now. So let's just get rid of the lerp, and we'll unhook the lerp here. So you can split your rotation structure, plug in your pitch value here, And you could reference the original yaw as well, or you can leave it disconnected. You know, that's not going to change much. And we never modified the roll once in this, so you can leave that whatever. And this would accomplish the same thing. Just like that. Maybe you don't want it to go center, so you can hook up your original yaw, compile like that. And when you shoot the thing, it'll just go straight down like that. So remember, coding is just problem solving, right? So there's a lot of different approaches to solve a problem. So don't feel like you have to do it a very specific way. It's just whatever works for you. So I'm going to keep it the original way, just because you know, it's the same above, so it's easier to understand for me anyways. So I'm going to plug in my lerp alpha, go back into my camera, and I'm just going to delete my pitch track. Compile and save, and then we're back to how we had it. Now the other issue with this code right now is the camera's being disabled. Well, there's two things. It's disabled, but it still sees me, right? The doors close, it triggers the alarm state. So that's no good. The other issue is when I shoot the actual camera, it's not detecting the camera shot. I'm hitting the trigger box, so you can see it. Not really good. Also, I can shoot it multiple times, so I got to fix that. So there's a few things wrong with this. So I think the first one we'll tackle is hitting the right trigger. The only way that I can think to fix that is adding a secondary trigger box. So right now we have this giant collider. We can simply go to our camera, add another component. You can search collision. I'm just going to do a simple box collider. And then I'm going to name this. I should start with trigger damage. All right. And then I'm going to scale this down a bit. And then I think I like that. Not perfect, but you know, it's good enough for what we're doing right now. But yeah. All right, so we can compile that. So now we have two colliders. So in our bullet, we can actually filter what we're actually hitting. So when on the overlap, when we cast to the actual camera, we can simply get a reference to our current trigger, which is our bullet. So you know, like the bullet reference, and then as the camera, we can get a reference to trigger damage, which was that new trigger I just created. So now we got both of these, and we can run a function called isOverlapping. You got actor and you got component. The actor is the entirety of the blueprint, so we can't use that because if I reference anything in this blueprint, it's going to return back true because it's part of the actor. So we want to do component. Components are specific parts of an actor, and that's how we can filter this. So it doesn't matter which component one you pick, whether it's bullet or trigger, just delete the reference. So like you can just select this, hit delete, and then plug in our actual ones that we already got. So, and these can go in any order. It doesn't matter. It's just basically checking, you know, these two things, are they touching, you know? So it doesn't matter if you plug it in like that or vice versa. With this in place, you can drag out your interface code a bit and just call off and do a branch check. And then if it's true, run this code. If it's false, do not. So if it's false, let's do a simple print string and say maybe, ha, you missed me. Compile and save. And now if I just shoot, nothing happens. If I shoot at the camera and I hit a component that's not the right component, it'll say, ha, you missed me. But if I hit the actual camera, like the body, it goes down. The problem is I can still shoot it repeatedly, so let's fix that real quick. We can go back into the camera body. And to address that, I think the easiest way is just add a Boolean. So in our variables, we'll add a isDisabled check here. And then you're simply going to drag off and you're going to set it at the end. And we'll set it to false. And in the beginning, you're gonna do a check. So you're gonna do a get, drag off your interface function, and do a branch check. Plug in the condition. If the camera is disabled, I don't want it to disable it again. But if the camera is not disabled and it got shot, I want to disable it. So I'm going to plug the true pin into the false pin, like so. But then I also want to set the disable to true. So I can get the is disabled, do a set, plug in this pin here, and set that to true. So basically it checks it, is it disabled? If it's not, it's set disabled to true. Run your code. At the end of your code, set it back to false. And if we play that, I hopefully will not be able to shoot this thing multiple times. So you can see it's not doing the funky stuff it was before. And then the other thing to check was the, so it can't execute an alarm state when it's disabled. That's going to be more of the, we're going to basically use this check in the collision event. So on the collision check, you can just drag this back, get a reference to is disabled, and then do a branch, plug in your reference. If the camera is disabled, it shouldn't be able to run an alarm state, right? Because this code effectively creates an alarm state. So we want to put this on the false pin. And now you should have a working camera system. So if it's disabled and I run in the trigger, nothing happens, I can go through the doors. If the camera's operational, and then it finds me, shuts the doors, sets the alarm state, maybe plays some music, you know, kind of whatever you're doing there. But yeah, there's still some bugs with it. I think there's enough bugs in this project now where I could probably wait till the end, and then we'll just do a maybe a bug squashing video because there's quite a few. But it still demonstrates a lot of the fundamentals, so I think it's pretty good. But yeah. All right, everyone, we'll cut it there, as the code to set up the destroy function is going to take a bit, and I think the short form videos are typically preferred, and I think this one's already long enough. But yeah, leave me a comment. Actually, let me know if you prefer the longer ones, or if you are like everyone else and you prefer short form. But yeah, as always, thanks for watching, and I'll see you on the next one.